Hello students, today we are going to solve a question from CSIR Net 2020, question number 67, and this is basically from molecular physics. So in that question, it is given that HCl molecule shows pure rotational spectra, okay, and also that first 5 absorption line in the rotational spectra is given. The location of first 5 absorption lines in the absorption spectra that is given. So this side you have a intensity, wave number in terms of centimeter inverse, and this side you have a intensity noted by I. So first 5 line is given as the location of first line in the absorption spectra, that is 80.03 centimeter inverse. Okay, and then next line location is given as 103.73 centimeter inverse. That next line is given as the location of next line is 124.30 centimeter inverse. The next line is 145.03 centimeter inverse, and the last line is at 165.51 centimeter inverse. So from these 5 lines in the absorption spectra, the location, we have to calculate the moment of inertia of HCl molecule in SI unit. So as you know, that separation between two successive lines in the spectra, that is noted as 2b. Okay, but we can see if we calculate that constant or separation between two successive lines in the rotational spectra, there will be slight deviation in that value 2b. That will not be constant, that will be almost same values, but there will be small deviation. That is actually experimentally expected. Why? Because of centrifugal distortion of rotational energy levels. Okay, so first of all, in that scenario, how will calculate that 2b, or how will calculate 2b? So you have to take the separation of these lines, and we have to take the average value. That will be the actual 2b. So if you calculate that separation between these two lines, 2b on, that will be 103.73 minus 80.03 centimeter inverse. Okay, so if you calculate this number, you will get 20.70 centimeter inverse. Okay, then next, if you calculate this separation between these two lines, that is noted by, this is your 2b on, this is your 2b2. If you calculate 2b2, that will be nothing but position of this line, that is 124.30 minus position of this line, that is 103.03 centimeter inverse. Okay, so if you calculate this number, you will have this separation, that will be 20.57 centimeter inverse. Okay, similarly, if you calculate this separation noted as 2b3, so we calculate 2b3 here, that will be 145 position of this line, that is 145.03 minus 124.30 centimeter inverse. If you compute this value, you'll have 20.73 centimeter inverse. And lastly, if you calculate this separation noted as twice b4, obtain this value twice b4, that will be nothing but 165.5 on location of this line, 165.5 on minus 145.03. Of course, unit is here centimeter inverse. Now if you calculate this number, you'll have 20.48 centimeter inverse. So you have a values of 2b1, 2b2, 2b3 and 2b4, and B symbol is known as rotational constant. This is the fingerprint of molecule. Now I will calculate 2b. So 2b, just you have to take the average values of this twice b1, then twice b2, twice b3 plus twice b4 divide by 4. Okay, so you can see from here that twice b1, b2, b3, these separation are not constant or not same. There is slight deviation that is actually experimentally expected because of centrifugal distribution distortion of molecule. Nothing is perfect rigid. Okay, so if you calculate now, you will have 20.7, then 20.57, then you will have 20.73 plus 20.48 divided by 4. Okay, if you calculate this value, you will get 20.62. Of course, unit here it will be centimeter inverse. It means in meter inverse, so this is centimeter is nothing but 1 by centimeter. Now if you multiply by 100 and divide by 100, so 100 centimeter, that is nothing but meter, right? So in meter inverse, it will be basically 62 meter inverse, which implies that B will be here, that will be 1030 on meter inverse, and that is nothing but h by 8 pi square IC, that we know, right? So we have obtained that value of B, and we know the expression for rotational constant B, right? Now everything is known, only unknown quantity is moment of inertia that we can evaluate now. So we'll have I, that will be nothing but h is nothing but 6.6 into 10 to the power minus 34 in SI unit, and then we'll have 8 pi square is nothing but 3.14 chi square, and then you have C in SI unit, that is nothing but 3 into 10 to the power 8 meter per second, and then you have a B that is evaluated 1030 on. Okay, so now if you calculate, of course, everything you have taken in SI units, obviously the unit of moment of inertia, that will be kg meter square. Now if you evaluate or simplify this expression, you will have the value that will be 2.7 into 10 to the power minus 47 kg meter square. Okay, so this will be the moment of inertia value of this molecule. Okay, so this will be the answer. Thank you very much.